Hello friends, in this lecture we discuss construction of Turing machine that accept a regular language having all the strings in which even number of zeros and ones both. Okay, so we have a regular language L that is having the string which is constructed over 0 comma 1 asterisk, and all the strings W having even number of zeros and ones both. Okay, so of course we know that this language L is regular. So here we are trying to construct a Turing machine for this language L. Okay, so first of all we discuss a regular set that is described by this regular language L and string S having the string null. In a null string, both the number of zeros and ones are even. Okay, it is the concept. Okay, so null string is belongs to L. Okay, and of course this string having even number of zeros and even number of ones, because the ones are present absence here. Okay, so string 1 is also belongs to this language L. Okay, a string this is also belongs to language L, and all these strings belongs to L. Okay, so so this regular set described by a regular language L. Okay, so next here we discuss one more thing, how this S is constructed. Okay, so for this we recall S is set of all strings having even number of zeros and ones both over the sigma. Okay, so all the strings over the sigma 0 comma 1 asterisk. Okay, so actually you can write asterisk also. Okay, so this, so if we consider as complement of S, that is represented by S bar. Okay, that is constructed by the union set minus S. Okay, so difference of union minus S is given like this. Okay, so the string 0 is not belongs to S, and 1 is of course not belongs to S. 0 1 is not belongs to S, because in these strings there is no even number of zeros and ones. Okay, therefore this is the complement of S. So all string belongs to S are belongs to language L, but all string which is belongs to S bar does not belongs to L. Okay, where this U is a universal set. Okay, if we are talking about a universal set over a sigma 0 comma 1 asterisk, then that is described by all set of strings over 0 comma 1s. Okay, and if we minus, okay, if we minus from this universal set S, then we get the S bar. Okay, S complement, that is the strings in which number of zeros and ones are not even. Okay, that is what S bar. So the string belongs to S bar is not accepted by language L, and our constructed Turing machine should reject those string which is belongs to S bar. Okay, I hope you understand what actually we want to construct in this situation. So we construct a Turing machine that accept all the string W belongs to S and reject all the string W which is not belongs to S, or we may say belongs to S bar. Okay, so here we try to construct a Turing machine for this. Okay, so let's proceed. So here we construct a Turing machine. We started with the transaction sequence by assuming an initial instantaneous description, and here we take the string 0 0. Of course, this string is belongs to S, so it should be accepted by our constructed Turing machine. Here we design a transaction diagram for our Turing machine. Okay, so let's, of course, the logic is very simple. Even number of 0 and even number of 1s means once we read a 0 or a 1, okay, we move to the odd one state, okay, and after reading the second occurrence of either 0 or 1, then we again uh, come back to the state which is representing the even of either 0 or 1. I hope you understand. If let's suppose if we are or are only interested to uh, construct a Turing machine having the even numbers of 0, then we construct like this, okay, like this. Here we start q0 and okay, and this is our final state. And if we read 0, then we move to this situation. This is indicating what? The odd occurrence. And again, for the even occurrence, we come to this situation, okay. Of course, we discussed this construction in our previous lectures also, okay. So according to this concept, we design a Turing machine for this language also, okay. So once we read 0 at q0, then we change its state from 0 q0 to q1 and process this 0, okay. For that, a transaction function like this, okay. This is q0, which is initial state, okay, and we adding this transaction function on reading of 0, okay, we replace it by 0, or we may use blank here also and move to the right hand side direction, okay, and change the state from q0 to q1. When we move from when we reach to a q1 after reading 0, it simply indicates that the odd zeros are processed, okay. So with this, if we apply this transaction function at this transaction sequence, then we get, or we change into the sequence like this, okay, where this 0 is processed, okay, this 0 is processed, okay. So we may need to be changed here. This is what? Blank, okay. Sorry, there is a misprint. This is what? Blank, okay. Please correct it. So this is our sequence again. At q1, if we are reading 0, then we come back to q0 again, okay. So if we, for this, we have first write a transaction function like this. Again, this is also be a blank, okay. Please correct it, okay. So we we apply this transaction function at this transaction sequence, then of course we move to a next situation like this, okay. This is q0, okay. This 0 is processed out or and replaced by blank, and we move to this situation. Now now in our input string, 00 is processed. It is indicated by this blank, okay. When once we reach to a blank, it means our input string is processed. If the processed input string having the even number of zeros or even number of ones, in case of this example, we just process even number of zero. So we reach to a final state, okay. And of course, this is the halting situation, okay. And this halting, and we consider this q0 as a final state, okay. So this halting is treated as an acceptance, okay. I hope you understand this, okay. Let's discuss for another example, okay. Let's assume one more string, 1 1, okay. At this situation, of course, this string having even number of ones, so it should be accepted because it is belongs to s also, okay. So in this case, again, with the same concept here, when we read 1 at q0, then we move to a odd one state, means a state which is representing the odd occurrence, okay. So here we consider state q2, and we add, for that we add one more transaction like this, okay. So if according to this transaction functions, we apply at this transaction sequence, okay. So we get the next transaction sequence is like this, okay. So you understand by this, okay. We this one is processed and replaced by blank, and we take a left turn, sorry, right turn, and move here like this. Okay, at Q2 again, if we read 1, then we process this 1 by overwriting it by blank, and this time we again move to by applying this transaction function again at Q0. Okay, so at Q0, when we're reading blank, it indicating the input is processed. Okay, and this is, of course, we keep it halt situation. Okay, if our input string is processed, because at this state Q0, if we're reading blank, it means our input string is processed. So and for this we don't have any further choice to move, because for the blank we don't write any transaction function in this Turing machine. So this is a halting situation, and of course it halting at a final stage, so it representing the acceptance of string 1 by this Turing machine. Okay, of course, student, this is not a final Turing machine for accepting all string which is belongs to L having even number of zeros and ones. For that we may choose to one more or more strings. So let's discuss for those strings also that complete our Turing machine. Okay, that's complete our Turing machine. Okay, so for that, of course, we're taking one more string like this. Okay, so if we process this, okay, at Q0 again, if we are reading 1, so we have a choice of applying this transaction function. So we apply this transaction function at this transaction sequence, or we can say initial instantaneous description. Okay, so we apply if this transaction function, then we lead to a next transaction sequence like this. Okay, here this one is processed and replaced by blank, and we take a right turn like this, and we come to a state Q2. At this Q2, for 0 we don't have any transaction function, so first we create a transaction function in this situation. Of course, this is for this was for odd number of ones. Okay, and now this time we write for odd number of zeros, so we add one more transaction function like this. Okay, at this situation. So we will write this. Okay, so like this. So we include this transaction function, and we apply this transaction sequence at this situation, that we come to a next transaction sequence like this. Okay, so in this situation, we earlier we processed 1 and replacing it by blank. Again we process this 0 and replace with this blank, and we come to this situation Q3. Okay, now at this Q3, okay, if we are reading 0 again, okay, so this 0 is what? The uh, even number of zeros. So again we move to this situation to go back with this situation. Okay, Q2. Okay, that representing even number of zeros. Okay, so for that we include one more transaction function like this. Okay, so when we apply this transaction function at this transaction sequence, our next transaction sequence is like this. Okay, so at this situation we processed even number of zeros. Okay, like this. Okay, but here, but odd number of ones. So I repeat again, at this situation, in this situation, before this, we please clear it. Okay, so at this situation, we processed odd number of ones, okay, and even number of zeros. Okay, so this is telling at state Q. Okay, so the state Q2 is representing the processing of odd number of ones and even number of zeros. So okay, so like this Q1 state is representing the odd number of zeros. Okay, and this state Q0 is representing even number of processing of even number of zeros and even number of ones and even number of zeros. Okay, so so again we come to this situation, and here when we read 1 at Q2, then of course by applying this transaction function we come back to this situation Q0. So we apply this transaction function because we already have this transaction function. So we apply this and come to a next situation like this. Here we are at Q0 and we reading blank. It simply means that our input string is processed, and of course our input string having even number of zeros and even number of ones. So it is counted as what? Acceptance, because here we halted because we're reading blank at Q0. So this is the halting situation. So again, this is halting and halting at final state because Q0 is a final state. So it is also known as acceptance. Again, we choose one more transaction, one more string, okay, and understand the remaining part of Turing machine. So, or that complete this Turing machine. So, if we choose this type of Turing machine, okay. So, student, one more thing you have to note here in my very first lecture of construction of Turing machine, I tell that before we starting construction of Turing machine, we have to just think over the sufficient number of strings. For that, we want to construct our Turing machine. For thinking about all possible set of strings, string gives us a proper universal Turing machine for that language. Okay. Otherwise, beyond our consideration, some strings which really belongs to the given language may be not accepted by our constructed Turing machine. So it is better to think for all type of strings that makes our Turing machine complete for accepting and rejecting the string which is belongs to or not belongs to the given language. I hope you understand this. So here we are choosing a different type of strings that make our Turing machine as complete unit for a given language. Okay, so in this case we are using the string 0 1 1 0. Okay, so of course when we read 0 at Q0, then we have a transaction function. This we apply this transaction function at this sequence, then we proceed in such a way. Okay, and including two more transaction function like this, okay, as in previous. So once we reading this 0 at Q0, then we apply this transaction function and come to this situation. I hope you understand this. And at this situation we are reading 1 and we are at state Q1, then we apply this transaction function. Okay, so after applying this we come to this situation, and again this is applied and we come to this situation, and again we applied this transaction function and we come to this situation. Again here we come to a situation Q0 state and we're reading blank. It means our input string 0 1 1 0 is processed and accepted because it having even number of zeros and even number of ones. Okay, I hope you understand this. For now, this Turing machine is a complete Turing machine that accept all strings having even number of zeros and ones, which is accepted by this Turing machine. If the string does not having even number of zeros or even number of one, that is rejected by this Turing machine also. So this is a complete Turing machine for a language L. Okay. Now here we're discussing tuples of Turing machines. So according to this transaction diagram or transaction function, we may create transaction table. Okay, and according to that or this transaction diagram, we may define tuples. Okay, so the tuples are like this. So we have a state 4 state and tape symbol 0 1 blank, and B is a blank symbol, and our input string is sigma is 0 1, over which our input string is constructed. Our assumed initial state is Q0, and Q0 is initial state and final state is also a Q0, and transaction function is given in a form of transaction diagram. You may create a transaction table for this also. Okay, by current state is Q0, and for a tape symbol 0, For a type symbol 0, we may write like this. Okay, so if we're reading 0, then we process override 0 by blank and take a right turn and move to a next state q1. Like this you may create a transaction table for this transaction diagram also. Thank you for watching. I hope you understand. If you have any doubt, then please mail me at this. Okay, and for this same problem there are language 2 and language 3 and language 4. Okay, so language 4, this is the new problems for as similar to this concept. Thank you again for watching this lecture. If you have any doubt, please mail me at this, and the reference of the topic is these.